This is the last lesson we'll do kind of in this section of the module. We're going to take a break then at the first part of next week, review a minute, pause, and then take a quiz just as a touch point to check. All right, how are we all doing? Like, are we all getting the stuff that we're talking about right now? So plan on a quiz next week. When we talk about in 5.4, what we're going to talk about today is how to utilize your calculator even more. We've done some RAM programs, doing trap and simp, and we're going to do one other thing that your calculator can do today. All right, so here's what we're setting that. I've kind of drilled it into you. You need to understand that the integral symbol is indicating area. The area is trapped between the f of x curve and the x-axis, and it has boundaries from A to B. All right, so how do you evaluate that? You just spent most of last night doing the geometry. Go ahead and put by hand on here. All right, you do the geometry by hand. You use circles, rectangles, triangles, trapezoids. And you even used a little wedge of a cubic, but they had to tell you what the little wedge was worth, and then you could do more geometry from that. All right. What limitations do you face then? So what if it's not one of those? Like, what if a trapezoid doesn't fit, and what if it's not a nice circular shape, but what if it's an oval shape? And what if, it's a heavens, what if it's a sine curve? Like, what do we do? Okay? All right, well, your calculator is to the rescue on this. Okay, we're going to use the Math 9 feature on our calculator. So this was going to be using the calculator when geometry doesn't fit the situation. All right, so if you're thinking ahead and you think there's going to be a quiz, and the quiz is going to have two parts, one where you don't get your calculator to use and one where you do get your calculator to use. What am I going to want to see on the non-calculator part? Okay, what have we done so far? What am I going to want to see you and show me that you know how to do? Okay, but before, like the very first day, what did we do this semester? Okay, we did RAM. We did the different kinds of RAM. So on a non-calculator part, I'm going to need to see that you know how to do a couple RAM, not a lot, I'm not going to ask you to do 50, okay? But I might ask you to do like a RAM 3 or a RAM 4, okay? Or a trap 3 or 4, or I will not ask you to do simp, okay? But RAM and trap, the different. And I'll ask you to do other geometry figures like circles, triangles, that kind of thing. So you should know how to do it without your calculator for the basics. When you get your calculator, now we're going to improve the accuracy because I'm going to let you run programs, and then you can do, 50 subdivisions, and you can run Simpsons, and then you're going to do what we are going to learn today. So it's going to be both. I need to know that you know how to do it, but I need to know that you can apply it to more complex situations where the calculator is helpful. All right. Would you go to your y equals, and would you put the function in here that it's asking us to do? All right, I'll put parentheses and insert some parentheses here. Okay, so let's go. You're in radian mode, so you're in y equals. And you're going to put x, sine of x. And then I'd like you to set the window to match the boundaries that are given. Okay, so set your window to -1 and 2. And because this is a sine function, we know that sine waffles between amplitudes, so we're not going to need 10 and -10. We don't need that much. All right, so go ahead and use, shrink it down a little bit, maybe do 5 to -5. Like, it doesn't have to be as big as normal. Then take a look at the graph. And then I'd like you to draw the visual representation kind of down in that bottom area where it says connect it to the visual representation. Okay, so make a drawing of what you see. Label the boundaries from -1 to 2. And then to the best of your ability, sketch.
What?
I have a line.
What does yours look like?
We just have a straight line.
That's not what mine looks like.
What mode are you in?
Gradient.
Gradient.
Me too.
Very down.
The point was here to understand what we're looking at. We are looking at the exact area trapped between this trig function and bounded from 1 to 2. That's what we're looking for. Whoops. So why is geometry not going to be ideal in this situation here? There's no geometric shapes. Okay, there's no rectangles will be too big or too small. Trapezoids will be too small. We're gonna, there's no circles or triangles or anything that we can use. So Math 9 is the option that we're gonna use. All right, now go to a home screen, okay, not a graphing screen, but a home screen, and then pull up Math number 9. So hit Math button, go down to number 9. What does it say by your number 9? FT, or does it say FNINT?
Oh, I mean FNINT.
Okay, that means, what does INT sound like that we've talked about? Integral. FN stands for function integral. So activate it. It puts in the integral. Go ahead and put the boundaries in to the right spots. Put your function in there, x sine x, close the parentheses, and put dx on the end. Okay? And make sure your window is set correctly. So sketch first, sketch your understanding. What's the O? I think you're crossing way too close to 6. It should be crossing at 2. I don't think it goes up at all. Where does it start? There. Okay, still should look like a parabola. Are you looking at the graph?
No, I'm trying to.
Yeah. You should know that. Just plug the number 0 in there and make sure. Okay. Okay, so go all the way down so I can see. Go all the way down because it's got to line up with where you put 6. You can just keep going down. So I want you to see how much negative area there is. A lot. All right, you're showing me too much. You're not showing me the right interval. You're showing me, I only want to see 0 to 6. Okay, that's all I want to see. That's what I want to see. What do you expect the net area, what do you expect the sign of the net area to be? Negative? Why? There's so much more negative area. Okay.
Negative one.
Oh, yeah, no, you're right, gang. But like, I meant,
100 more.
that's a lot of, that's a lot of 60.
That's what you found.
All right, so that's kind of what I usually do if you want to look at the screen. Okay, so my negative area is the stuff that's underneath the x-axis. I usually make that red because it's negative. And then when I flip it to the positive, then that's going to be, I make it green. You can do whatever you want, but that's how I set mine up. Okay, Brendan, you want to give me the first one? Give me the net area. Okay, negative 48 is the net area because so much more of it is negative than positive. All right, did you get a total area? 6. Okay, at least 3, and that'll be total. All right, good work. All right, let's keep going. Okay, now I'm giving you a y1 and a y2. All right, a y1 and a y2. Go ahead and graph both of them. I want you to put the sine function in your y1. Make sure you close your parentheses at the correct spot. And then the other one's just a line. And then take a look at the window. Take a look at this. So we have a sine function and a line function. All right, so hopefully yours looks something like this. Okay, we want to find the area between these two functions, the total area between these two functions. All right, so what do you notice happens when they intersect? They change places, right? Okay, because one of them is the upper function and the other one of them is the lower function. And then they trade spots. All right, we need to figure out where this is. You guys know how to use your calculator to do that? Okay, find the intersection. So second trace, go to the intersection, and have your calculator calculate that. All right, I get 0.511. Okay, but that's a rounded one. Now this is an important step, so I need everybody to have done this on your calculator, so your calculator has that stored in its memory. Does anybody need a little bit more time to do that?
Yeah.
Okay, I need you to have calculated the intersection so that your calculator has that stored in its memory at the moment. Okay, go to a home screen. Clear everything out of that, just clear. The next command I want you to do is store. Store is right above your on button. So hit store. Oh, bummer. Okay, never mind. Back that up. Go to, what's above your negative key?
3.
No, like right above it in a different color. Answer. Okay, activate that first. So that means take the answer you just found, then store. Okay, and we don't want to store it in X, we want to store it in a different variable to take the place of it. So always use A, so hit the alpha button on your calculator and pick alpha A and hit enter. So, and then you should see that same number right there. Answer is above the negative sign. Okay, so now our calculator has been assigned this value as A. All right, now we're going to take two math 9s. One math 9 that goes from 0 to A. Are you on a home screen? Was the last thing that you did to find the intersection point? Okay, then hit answer, which is second negative, then hit store, and then hit an alpha variable. I picked alpha A. Okay, so the first math 9 we're going to do is to go from 0 to A on our calculator. And because we're doing total, we're going to do absolute value. And we want to do the one that's on top in that section. So we'll be finding the area between them right here. So the one that's on top is 2 minus x. And then we subtract the one that was underneath. Sine x minus 1, because you have to distribute the subtraction. That's your first math 9, and that'll find the green section. So hit enter and tell me what you get. Anybody got it? Or you're typing? Say it again. 0.253. Did anybody confirm that? Okay. The second one is going to start at what variable for its lowest value? Start at A, and where's it going to end at? 2. And in this one, in the absolute value, we put the sine x plus 1 first, and then we put the minus 2 plus x. So we subtract and put that in absolute value, and we'll come up with that one. That's going to give me the other side. And then who's got that one? $1.669. Anybody confirm that? And then add those two together. You could also use y1 and y2. If you don't like to do, you could do y1 minus y2 and y2 minus y1. You could do it that way also. Okay? That's how you do two graphs at the same time.